Starting in Chapter 8, Reciprocal Function Family. What is the reciprocal function family? The reciprocal is if we have x, the reciprocal would be 1 over x. So today we're going to be talking about functions like 1 over x and transformations of that function, just like we just went over for logs and exponents. I would not write this down. Don't write this down. Write the next slide down. This is just me going over the reciprocal. So our parent function is 1 over x, and that's going to be the same always. Now, we have this function to rely our transformations off. One thing that always has to be true is x cannot equal h, because then that would have 0 on the bottom, and you can't have 0 on the bottom of a fraction. Now, when you look at the parent function, here, there's two things you have to be clear about. There's a vertical asymptote, so a dotted line that goes up and down, and then there's a horizontal asymptote, a vertical line that goes left to right. And then we have the typical parent function on the upper right hand corner. It would show a U almost touching both of those two asymptotes, but not completely, and same thing in the bottom left hand corner. So that's what our parent function looks like. So what is our thinking process? So you should be writing this down. You should write this down so you have something for a reference. First, you have to know the transformation. Just like all other types of functions, the a, if it's negative, it's going to flip the equation. If a is going to be greater than 1, it's going to have a stretch. And if a is going to be less than 1, it's going to be compress. So just like we have dealt with before. The h is always opposite. The number with the x is always opposite that's shown. So if it's going to be negative, it's actually going to move to the right. If it's going to be positive, it's actually going to move to the left. And finally, we have our k. K is for our y. So if it's negative, it's going to move down, and if it's positive, it's going to move up. So, first question you always ask yourself, what is the transformation? Then when I'm figuring out what the vertical asymptote is, did it move left or right? Because if it moves left or right, that's going to change the vertical asymptote. Typically with our parent function, we always have x equals 0, but if it moves left or right, that's where that changes. For horizontal asymptote, did the function move up or down? Because typically it's going to be y equals 0, but if it moves up or down, that's going to change that number. And the y-intercept is what is y when x is 0. So you're actually going to have to plug 0 in for x and figure out what y is. And x-intercept, what is x when y is 0. And this is always going to be one that you want to use your calculator to check to make sure you have the right answer. So now practicing my transformations here. This right here, since it's positive, it's actually going to move left 1. And this right here, since it's negative, it's going to move down 2. So now when I talk about my vertical asymptote, vertical is going to deal with left or right. So it typically starts at 0, but now it's going to have x equal to negative 1. Horizontal asymptote, that deals with the down 3. So it typically starts at 0, but now it's going to be y equals negative 3. My y-intercept, if I plug 0 in for x, so this is my work down for my y-intercepts. If I have 0 plus 1 minus 2, that's going to be 1 minus 2, or that's going to be equal to negative 1. So my point I write here, I plugged 0 in for x, and I came out with negative 1 for y. And finally, if I have my x-intercept, if 0 is equal to 1 over x plus 1 minus 2, and if they solve that, so I would have 2 is equal to 1 over x plus 1. Now here's where it can get a little tricky. You want to make sure to put this into a fraction, equal fraction, and cross multiply. So in this case it would be 2 times x plus 1 is equal to 1. And when I solve that, you can do that one of two ways. You can distribute the 2 to have 2x plus 2 is equal to 1. That's a plus. Subtract 2 from both sides. 2x is equal to negative 1. Divide by 2. X is equal to negative 1/2. So for this point, I plugged 0 in for y, and I came out with negative 1/2. So when you're graphing this, go step by step. So first, I'm going to graph my vertical asymptote. X is negative 1. That's at this spot right here. Vertical asymptote means it's a dotted line up and down. So it's going to be this line right here, and you should always label your asymptotes. So this is x equals negative 1. And then I have y equals negative 3. So negative 3 is right here. And put your dotted line. And then I have 2 intercepts. So 0, negative 1 should go through this point. And negative 1/2, 0, this point. So when you're graphing this, the shape should get close to your asymptotes. It does not have, or it should not go through it. And that is all. For this next problem, you should pause it. Yes, pause it, and first tell me what the transformation is. You should have gotten up 4, or right 4 and up 6. So right now I want you to pause again and see if your vertical and horizontal asymptotes match what I have. And you should have gotten x equals 4 and y equals 6. And for the last two, when you plugged 0 in for x, you should have gotten 5 3/4 up for y. And when you plug 0 in for y, you should have got 23/6. And I'll show you how to check that on your calculator in class. So now I'm going to graph all of these. So x is a positive 4. That's a vertical up and down. And I have a horizontal asymptote at 6. And then I have, so I'm going to make sure to label those. X equals 4, y equals 6. And my points, 0 and 5/3. About right here. And 23/6, so almost 4. But not quite there, 0. And then it looks like your parent function. Almost touching the horizontal asymptotes, but not really. Make sure you wrote down all of that. Make sure you have your thinking process written down as a reference. And have a wonderful day.